This drone serves as the eyes of the American infantry, having logged over 1 million flight hours. It transforms an ordinary brigade into a high-precision mechanism capable of seeing the enemy from 125 kilometers away. The RQ-7 Shadow is the primary tactical UAV of the US Army, designed to operate in the interests of ground commanders. It is not a strategic giant, but a resilient workhorse of the front, transported by several Humvee vehicles and deployed in field conditions. Its uniqueness lies in its rotary engine and a landing system utilizing aircraft carrier technology, hook and cable, allowing it to use short forest roads instead of airfields. In the Block 3 version, the drone has become a digital slave to Apache helicopters, allowing pilots to destroy targets they cannot even see on their own radars. Instead of conventional pistons, the Shadow uses a 38-horsepower rotary engine that delivers immense thrust with minimal weight and dimensions. The Vankel engine allows the drone to climb quickly and maintain cruise speed, even with a full payload. The rotary design produces fewer vibrations compared to standard internal combustion engines, which is critical for the stable operation of a laser designator at distances of several kilometers. The engine runs on aviation fuel, standardized with NATO equipment, simplifying logistics on the front line. However, due to its high-pitched sound, this drone earned the nickname Flying Lawnmower, as it is clearly audible at low altitudes. The drone's tail assembly is inverted into a downward-facing house shape, not for aesthetics, but to protect the pusher propeller and engine during hard landings on unprepared ground. This geometry serves as a kind of bumper. If the drone tips onto its tail during a parachute or airplane-style landing, the fins absorb the impact rather than the expensive engine and propeller. Additionally, the inverted V-tail improves the aircraft's maneuverability at low speeds, which is vital when operating in difficult weather conditions or during an approach to the arresting gear. The airframe construction itself is made of graphite composites, making it as rigid as steel but as light as plastic. The Shadow's fuselage is assembled from epoxy composites with a honeycomb core, a technology borrowed from the aerospace industry to combat wing deformation during high G turns. The use of honeycomb panels allows the drone to withstand immense G-forces when launching from a hydraulic catapult. The structure does not flex, ensuring the surgical precision of the POP-300 optical system. With a takeoff weight of 212 kilograms, the drone maintains a lightness that allows it to soar in the air for up to 9 hours, saving every liter of fuel. All this structural integrity is necessary to withstand the abrupt deceleration of the arresting cable during landing. The Shadow lands like a carrier-based fighter. It deploys an arresting hook that catches a cable stretched across the road, stopping the 200-kilogram machine within a few meters. This system allows the RQ-7 to operate on strips only 50 to 100 meters long. The short braking distance prevents the drone from veering into a ditch or colliding with obstacles at the edge of the site. If the hook fails to catch, the automation immediately applies full throttle, and the drone performs a go-around, exactly as pilots do on aircraft carriers. Takeoff is no less spectacular. A hydraulic catapult launches the Shadow into the sky with an acceleration that would turn a human to mush. The optical ball under the fuselage integrates an HD daylight camera, a thermal imager, and a laser rangefinder capable of designating targets for Hellfire missiles. The POP-300 is a gyro-stabilized platform that keeps the target perfectly still, regardless of how much the drone itself shakes. Digital zoom allows the operator to read vehicle license plates from an altitude of several kilometers. The laser designator makes the Shadow an indispensable spotter. The drone finds a target, paints it with an invisible beam, and the strike is delivered by tanks, artillery, or aviation. In the modern warfare of 2026, the Shadow has ceased to be just a spotter and has become part of a single organism with attack helicopters. MUM-T technology allows the crew of an AH-64 Apache helicopter to control the Shadow's sensors while positioned 50 kilometers away from the target. The helicopter sees exactly what the drone sees. This radically changes combat tactics. The helicopter hides behind terrain features or trees, remaining invulnerable to air defenses. The pilot directs the Shadow drone into the danger zone, locates targets through its camera, and launches missiles that home in on the drone's laser. The risk of losing a manned aircraft is reduced to zero, while the effectiveness of the strikes increases significantly. To transmit such a high volume of data, an ultra-secure TCDL channel is used. The Tactical Common Data Link, TCDL, encrypts the data stream so that intercepting the video or hacking the controls is virtually impossible, even for powerful electronic warfare, EW assets. This protocol provides high bandwidth, allowing for real-time video streaming without delays. The system is interference-resistant and operates across a wide frequency range. It is thanks to TCDL that the drone can transmit data not only to its base, but also directly to the tablets of forward observers and into helicopter cockpits. If the connection is severed, the Shadow switches to an autonomous return home mode using an inertial navigation system. The latest Block 3 modification features a new engine that runs quieter and cameras with resolution high enough to distinguish types of small arms held by infantry. In Block 3, Textron engineers addressed the primary issue: noise. A new exhaust system and rotor optimization have made the drone less acoustically detectable. The onboard electronics were also updated, now supporting AI algorithms for automatic target detection. Vehicles, artillery, groups of people, easing the operator's workload. Although the Shadow is primarily a scout, miniature teeth have appeared in its arsenal. When necessary, miniature precision-guided munitions can be hung under the Shadow's wings, turning the Scout into a light attack aircraft for neutralizing sudden targets. The Fury bomb weighs only about 6 kilograms, but possesses the precision of a surgical scalpel thanks to GPS and laser guidance. This allows for the destruction of individual vehicles or machine gun nests without waiting for attack aviation to arrive. However, mounting weapons reduces patrol time, so the Shadow more frequently remains clean as the eyes of the brigade. The full operation of the complex requires a ground station based on a Humvee, which is a true data center on wheels. The entire RQ-7 Shadow complex fits into the beds and trailers of 4 Humvee SUVs, allowing a brigade to change its reconnaissance position every few hours. The complex includes 2 ground control stations, GCS, a launch catapult, an arresting gear, and spare parts. High mobility ensures that the enemy does not have time to calculate the launch site via radio signal. Shadow crews train to deploy the system in an open field in less than an hour, making the complex an incredibly flexible tool in maneuver warfare. Such reliability is confirmed by a massive flight time in the harshest conflicts of modern times. The Shadow's total flight time exceeds 1.2 million hours, an absolute record for tactical UAVs, achieved in the skies over Iraq and Afghanistan. The Shadow became the primary provider of intelligence for the US Army during long campaigns in the Middle East. It operated 24/7, with units rotating over patrolled zones. Immense operational experience allowed for the identification and elimination of all teething troubles in the design, turning the RQ-7 into one of the most reliable drones in the world. But despite this success, the Army is already preparing a replacement in the form of vertical takeoff aircraft. The era of the Shadow is gradually coming to an end. It is being replaced by FTAS, Future Tactical Unmanned Aircraft System, drones, which do not require catapults or arresting gears. The main disadvantage of the Shadow in 2026 is its dependence on bulky launch infrastructure. Future systems will feature a vertical takeoff and landing, VTOL configuration, while retaining all the reconnaissance advantages of the Shadow. Nevertheless, the RQ-7 will go down in history as the drone that taught the US Army to fight in a unified digital space, where information is more important than gun caliber. It departs, leaving behind the standard for what 21st century tactical reconnaissance should look like.